Hello, good morning, good day, or good afternoon, wherever you join us. Welcome to our webcast, Use of MPU-based Controllers in Heterogeneous SoCs. This webcast is provided to you by SYSGO and our valued partner Xilinx, a leader in FPGA solutions. Xilinx and SYSGO have teamed up recently in order to present a complete multi-core solution for safety-critical markets. My name is Franz Wagenbach, and I'm glad to be your moderator today. And with that, I would like to introduce our speakers today. So from Xilinx, we have Dagan White. Dagan is a product manager for aerospace and defense. Then I would like to also introduce Dr. Oliver Kühlert. Oliver is the technical product marketing manager at SYSGO. Now I would like to introduce you to the agenda. So after a quick introduction of the companies, Xilinx will start with the introduction of the Xilinx UltraScale, setup of big SoCs and the use cases aligned to that. Then we will have our new product from SYSGO, which is called PikeOS for MPU. Also the introduction of our development environment called CODEO on both MMU and MPU-based systems usable. Then a couple of items on avionics certification, and then we have a demo video and conclusion. So before we go into depth, a couple of words on the Xilinx and SYSGO partnership. So as mentioned in the beginning, Xilinx and SYSGO combine solutions to provide support for SoCs, for the avionics and safety-critical applications. We are addressing together multi-core certification challenges spanning hardware and embedded software. The benefits for the customers are that we can guarantee software safety from design to deployment with certified automatic code generation and operating systems. There's also a seamless integration of software design and operating software integration, and a reduction of verification and validation cost and time. Also, we see a higher performance for safety projects with multi-core support with this joint engagement. Together, Xilinx and SYSGO, we can offer full compliance with safety standards. You see a couple of examples listed below. Having that said, I would like to hand over to Dr. Oliver Kühlert, who will first of all introduce you to the company and follow up.
Thank you very much, Franz. And hello, everybody. We will now continue with taking a closer look at the company SYSGO. So SYSGO started about 30 years ago in the domain of embedded software, mostly with x86 and PowerPC boards. Very soon there was a focus on Linux projects, and as a consequence, we developed our own embedded Linux distribution, which is called Xilinx. In about 2000, we started to work on certification projects, mostly in the avionics area, and we were the distributor of a foreign avionics operating system. At that point of time, well, it was 2003, we decided to develop our own avionics operating system, which is called PikeOS. It basically is a real-time operating system with virtualization capabilities, and it supports partitioning as requested in the avionics world. However, PikeOS is multicentric, and it allows also to run automotive, industrial, medical, and even space operating systems as well. And even Xilinx can be run in a para-virtualized mode running on top of PikeOS. SYSGO became a member of the Thales group a few years ago. So let's now see where we are, especially in the avionics world. So we are in cockpit display systems. The nature of the PikeOS operating systems allows to develop projects in the context of integrated modular avionics, IMA, and there we worked on cabin management systems, data servers, cockpit display systems, and for the A400M we developed the Loadmaster working station, which controls the rear door of the plane as well as the cargo load. We are also in satellite communication systems, engine control, and airport flight position measurement systems. So in space, we are as well as on the satellite itself, as well as the satellite control and the mission payload. We are also in ground control system, especially the Korean National Positioning System, where we developed the error correction of the GPS signal. Another topic in terms of PikeOS is also security, and we have a focus on security when it comes to space telemetry. Later on, we will see that we did a brand new project based on the Dahlia processor, which has been developed by the ESA. So why do customers choose SYSGO? So first off, let's take a look at the center at our product line. So as mentioned before, we have the PikeOS hypervisor, we have Elenos, and in addition to that, we have certifiable IP stacks and certifiable file systems. On the certification part, we provide certification kits for all major safety and security areas. For example, the DO 178C standard, the industrial standard, railway, and automotive. And on the security side, we reached an EIL level of 3+ for our PikeOS microkernel. Please stay tuned because there will soon be an update where we reach higher levels with our latest release, PikeOS 5. On the server side, we provide consulting for security, safety, product training, and our build servers can replay any software that we built the last 30 years and that we will keep up doing in the future, which means if you need support for an older system, we can replay that and recompile it and provide the software even on source code level. On the processor side, we are certified according to multiple ISO and common criteria processes. We have a very broad ecosystem of partners. For example, in terms of coverage, we have Lauterbach. In terms of multi-core analysis and worst-case execution times, we work together with Rapita. And we have multiple strong hardware partners, especially today, Xilinx, which provide great combinations of processors and FPGAs. The product is ITAR-free in contrast to US products. So I will now hand over to Deegan White from Xilinx.
Okay, today I'd like to start out giving you a little bit of background on Xilinx overall before stepping into some more detail here. So Xilinx was founded initially in 1984, and we've been building new technology platforms since then. We've had a number of firsts in the industry, starting with Xilinx is the founder of the FPGA, the first producer of an FPGA product. More recently, we've been in developing SoCs, and today, this past year, we've released our Versal ACAP, which is an adaptive compute acceleration platform, which is kind of a next level of an SoC. We do have a global footprint. Over that time, we've grown to be in excess of $3.2 billion today. We have a number of employees, approximately 5,000 worldwide. We service a broad range of customers and industries. And of course, with all the technology innovation, Xilinx holds a fair amount of patents. We are involved currently in an acquisition with AMD. So Xilinx will probably become part of AMD within this calendar year, 2021. However, we have the charter to maintain our focus on our multi-markets that we have and to continue developing technologies while also collaborating with AMD on new products. But we intend to maintain the focus, like I said, in the core markets that I'm showing here, which is aerospace and defense, automotive, industrial and healthcare, test and measurement, and audio, video, broadcast, and consumer, as well as our wired, wireless, and data center businesses. So wired and wireless and data center are their own business segments within Xilinx, and the other markets, aerospace and defense, automotive, industrial, and so forth, are our core markets. So I am a member of our core markets team. I'm in our aerospace and defense group, and I focus on avionics, missiles and munitions, and I manage our defense grade product line. So, within aerospace and defense, we service multiple application areas that we focus in, which is space. We have avionics, radar, and ISR, and EW. Defense systems, which is missile munition and other applications, and then MILCOM, public safety, and communications that bridges into SATCOM as well. And then we do have some homeland security business. So today I'm here to talk to you about our avionics business and solutions, and most notably the solutions that we built around the Zynq UltraScale Plus MPSoC. MPSoC and RFSoC really in the UltraScale Plus family are the same processing system and programmable logic. The RFSoC adds the high-speed analog capabilities, multi-gigasample per second, ADCs and DACs. But for all intents and purposes, from a certification standpoint, the Zynq UltraScale Plus MPSoC and RFSoC would be similar from a certification standpoint. All the core aspects are the same with added capabilities in RFSoC. Then going forward into Versal, as we roll out more of our Versal products, this will extend on the Zynq UltraScale Plus family from a certification standpoint. So a lot of what I'm talking about today would apply going forward. There are other architectural innovations and advances in the ACAP, but at least this conversation will set the foundation for how to consider certification on the ACAP as well. So as a member of our core market team, I work with our other safety critical markets, being namely automotive and industrial. They certify to ISO 26262 and IEC 61508 respectively, and we generally market these capabilities under functional safety and functional safety certification. So there's very similar aspects there to DO254 and DO178. DO254 being the focus for hardware aspects of avionics certification, and DO178 being the embedded side of certification for avionics. These other automotive and industrial standards are multi-part standards. They include both hardware and software and system level, which again for avionics there's of course other standards which I'll show on the next slide. However, the thing to note here is that there is requirements convergence amongst these safety critical applications. Of course, there's certification needs for safety, and then there are increasingly cybersecurity requirements. Well, I would just say pretty much cybersecurity requirements are now in all of these application areas, whereas in the past, 10 years ago, really this was kind of the focus of defense systems only. And now we are looking to incorporate more deterministic and probabilistic AI and ML functionality in these devices. And how do we do that? So that is kind of a question area and a focus area going forward for Xilinx. So overall, we have the common objectives across these markets to certify safe systems that can operate, that can be evolving, and also how do we do that? How do we allow development of these certifiable complex systems more efficiently and while maintaining safety? That's kind of core focus that we have across our functional safety markets at Xilinx. So if we look at the avionics standards a little bit more, I mentioned 254 for the hardware, 178 for the software. There are other system level safety and system development standards that apply. And those are, the collection of all these standards for avionics would be, synonymous with, the comprehensive ISO 26262 or IEC 61508. However, as mentioned, avionics has a little different take on things. But the key requirements that we really, look to service within Xilinx are the DO254 and DO178 elements, as well as SEU mitigation, which that bridges into some system level safety and system level availability kind of requirements. But we have very strong solutions there. Today, Xilinx has been adopted across a full range of avionics systems. We have 7 series products that are certified in commercial aircraft up to DAL A, approved by the FAA and EASA. Like I mentioned, our core focus is the certification piece and the SEU piece. However, we do have others, system architecture solutions within aerospace and defense, like for instance radar, or for instance, MILCOM, public safety communications, SATCOM. Those application areas are utilized within aircraft applications, and we do have some system level architecture teams focused on those areas that we can leverage here. Additionally, we have in Xilinx, display system and other, video kind of focuses. So the core piece that I focus on for avionics is the certification SU piece, but we do leverage these other system level architectural solutions that Xilinx develops. So today, we are designed into military aircraft, unmanned systems, drones. We're in commercial aircraft up to DAL A, as I mentioned, and we're being designed into a lot of these eVTOL, urban air mobility systems, which is definitely a growing area. So, what I focus on is staying in tune and with the industry and staying up on the subjective evolving standards here. We definitely understand there's a high engineering cost to develop these systems, and it takes time. It takes 3 to 5 years typically for our customers to get into production. So Xilinx is used to that. We do still support these markets that require certification, and we deliver a long product life cycle that is necessary in these applications. Our customers typically want 20-year lifetime, and Xilinx certainly has 16 plus years and 20 years in many cases with our product. In addition, high reliability of the device in the application is important. So Xilinx develops for a 20-year lifetime at 85 degrees C junction, continuous operation, and that would go to 10-year at 100 degrees C junction and 3-year at 125 degrees C junction. So we definitely build a high reliability product within Xilinx. We kind of check all the boxes here that are valuable for avionic applications. Okay, if we look at our DO254 and DO178 solutions, we really build this out with an ecosystem, which is why we're here today with SYSGO. This is kind of not within Xilinx's development process to develop DO254, a process on our IP development. And on the embedded side, while we do have functional safety focus, there's a lot of embedded elements that might not be covered under our functional safety, and certainly we don't have our own real-time operating systems that you need to certify with. So we partner with companies like SYSGO, and I have Logicircuit as a key partner for DO254 IP cores and other kind of lower level embedded work they do as well. But it's necessary for us to have a robust ecosystem in order to service this market. So I work with these partners directly, and I can engage with customers and partners directly. If we look at the families that we have, I did mention 7 series has been certified up to DAL A in commercial aircraft applications. We also have Spartan 6 and earlier products that have certainly been certified. I came into Xilinx around the time when 7 series was rolling out, and so that was kind of the focus of my efforts here. and that's where I have the most experience and where we certainly started taking hold more into avionic applications as we bridged out of 6 series into 7 series. We had very strong SEU there, which is also noted on this particular slide. SEU was very good in our 7 series products, the Zynq 7000, the Arctic 7, the Kintex 7, Vertex 7. But we improved it even further going into UltraScale architecture at 20 nanometer and 16 nanometer with about, roughly 8 to 10x reduction in SU rate, so improvement in system level availability with that. And then going into Versal now, we have the lowest SU rate of any product family. So as we've shrunken process node, we've actually, with our SU technology development, we've basically improved the SU rate. So anything recommended now would be 7 series, UltraScale Plus, and Versal for new designs, although I would really weight that towards UltraScale Plus or UltraScale, any UltraScale architecture device really, and Versal for new designs. 7 series would be there if you really need a smaller, lower density FPGA only product. But UltraScale Plus is really the focus here today, the Zynq UltraScale Plus specifically. So key messages on Xilinx and SEU. This is a whole subject that I could go into in greater depth than this, but I'll just say we're an industry leader in SEU. We have holistic device level characterization, and that's the memories, the configuration memory, the processor, subsystem. We have a breadth of device level SEU solutions available in terms of SEU mitigation IP. We have ECC on all of our memories internally in the device. We have tools. We have a SEU fit rate calculator available to give you a mean time between upset based on device, geomagnetic location, altitude, latitude, device utilization. So you can get SEU fit rates out of that. The data, the raw data we have scaled to the device and your application. And then, we have other architectural mitigation capabilities with isolation design flow, partitioning, and so forth. So there's a lot of things we have available to help with the SEU piece. And we have been deployed using these mitigations in DAL-A avionics. Our automotive and industrial customers are also using these products in safety critical systems. So if we look at the Zynq UltraScale Plus device, really there's multiple certification domains here. This is a monolithic device, piece of silicon. It's a monolithic piece of silicon, one piece of silicon with basically a COTS processor that's hard in the silicon on one part of the die, and then a programmable logic portion that's kind of the classic FPGA on another part of the die. And then these are interconnected with some signaling lines and definitely AXI interconnect. So in this way, you could view the programmable logic or FPGA as a memory map peripheral to this COTS processor. So if we look at this from a certification standpoint, on the processing system side, I work with Multicore for Avionics Group, which is the industry consortium of tier 1 companies that look to certify our product in these multi-core processors. So I have an MCFA data package available, and we do have the functional safety data package available for the processing system as well. And so overall, the processing system hardware has to be treated as COTS under DO254, but then there are multi-core certification objectives that ask questions around the development process, kind of getting at those DO254 pieces, but also focused in more detail on the embedded development and how you manage isolation and partitioning of resources to minimize interference and contention across resources in the multi-core platform. On the FPGA side, it's actually pretty much more simplified. It's basically there's COTS DO254 treatment for hard blocks in the device. Say like a PCI Express endpoint is just COTS silicon in this device. We have a video codec, right? That's COTS hard silicon in the device. But there's also custom DO254 treatment for for either third-party IP like Xilinx provided IP, or for custom development IP. So custom developed IP needs the full DO254 process. When you're using COTS IP like from Xilinx or IP libraries, in some cases you can treat that as a black box and develop test cases and verification to the boundary of the IP, and or use that with architectural mitigation. In other cases, you might seek to have a DO254 DAL A process or DAL B process, and for that we have LogiCircuit that can provide that kind of information for our IP cores. If I look at the MCFA data, we do have quite a range here available, covering development process for this processing subsystem through functional safety elements. So this is just a highlight of that kind of information that we do have available to support the Zynq UltraScale Plus MPSoC certification. Some of the key features that we have in this device to support high criticality applications include full ECC support on all the internal memories in the device. We have, like I said, a significant SU reduction over earlier technology nodes. The DDR memory itself supports full width data and ECC. We have lockstep R5 cores that can be run in lockstep or independently. We have isolation of the application processing system, the real-time processing system, and the programmable logic power domains, which can allow for partial SoC resetting, power gating of cores, etc. We have multiple levels of memory protection. We have a system memory management unit, Xilinx memory protection unit, Xilinx peripheral protection unit, quality of service monitors. So these all allow for, these are hardware features and mechanisms that allow for isolation and partitioning of resources to mitigate against interference and contention amongst resources. We have isolation design flow in the programmable logic where you can physically partition the programmable logic. And then, of course, we have the certification solutions that I mentioned already. If we look at multi-core certification process, Rockwell Collins Aerospace, now Raytheon Technologies, has done an outline. They have a white paper that they've done. So basically, they outline 15 steps to meet CAS 32A objectives. So I've identified those here on the left, numbered 1 through 15, and on the right-hand side in the more greenish color, I've basically highlighted what kind of material information or partner-based solutions that Xilinx has to offer at each step here. So before I hand it over, we have key information and links here for data. This is just here for reference, for your reference after this webinar. And with that, I'll turn it back over to SYSGO.
Okay, thank you, Deegan. We now continue to take a closer look at PikeOS. So here we see the architecture of a running PikeOS system. Below we have the hardware, which in today's case is the Xilinx UltraScale Plus board, of course. And the microkernel itself is very modular, consisting of the architecture support. This is where we currently have x86, PowerPC, MIPS, and some special space processors. If you have a custom board, there is a development kit where you can adapt the microkernel to your according platform. Of course, we have a set of reference platforms. The first software that the microkernel starts is the so-called system software, and the system software can be compared to the init process of Linux. It starts the different partitions, which can be thought as virtualization containers, and starts the different operating systems. Despite a Linux kernel, which handles this initialization dynamically, this all is configured statically, which means the Linux operating system or any guest runtime cannot get or cannot retrieve more memory at runtime than it has been assigned at system startup. So this is a list of the PikeOS guest operating systems that we are supporting. First off, our own native API, which is called PikeOS Native. ARINC 653, also known as APIX for the avionics world, Linux. This can basically be any Linux distribution, and we can run Linux as well in hardware virtualized mode or in para-virtualization. In terms of para-virtualization, you need a small adaptation to the Linux kernel. Although this works with any Linux distribution, we of course prefer the Linux distribution here. Next is the ADA environment, which comes from our partner AdaCore. This allows to run a ADA language on top of PikeOS. Finally, we have Android, which runs usually in hardware virtualized mode. If you have an older operating system, just as R10s or whatever, we can port it to be run on top of PikeOS. So when it comes to development, we have our own development IDE, which is called CODEO, and it bases on the most recent versions of Eclipse. It comes with the C development tool, CDT, pre-configured, and in addition to that, we have plugins for application deployment, usually via Ethernet, debugging. We have a built-in target simulator based on QEMU. We have a target system monitor, and as well for dynamic analysis, a target tracing tool. And this tracing tool provides you an oscilloscope-like view on the system. You can filter, zoom in and zoom out as you like, and even have a list of events which is searchable if you want to look into the details. The development environment is available for both Linux and Windows. When it comes to certification, we support all major safety standards. For example, DO 178C Del A for avionics, 61501 for industrial automation, and as well as railway standards, signal, wayside, and rolling stock, and also automotive, and all these standards can be certified up to the highest level. SYSGO has a very long history in certification projects, and almost every engineer of our team has been involved in such a certification project, let it be safety or even security. Here you can see the PikeOS components and their certification state. So you can see that the microkernel is fully certifiable, which means we can provide all the necessary documentation, including traceability and coverage. However, if you have your custom boards, the PSP needs to be developed together with you as a customer. When it comes to the operating systems and certifiable APIs, we have a certifiable POSIX, and of course the PikeOS native is pre-certified. Depending on your needs, we can certify further operating system. In addition to that, for PikeOS, we also provide a certifiable file system and a certifiable UDP stack. Another important topic when it comes to certification is the tool qualification. So basically, you can do a certification without any tools really being qualified as long as you verify the results. And if you do that on a binary basis, it is basically possible, but very, very tedious. Therefore, SYSGO has qualified the major tools, for example, the ROM image builder and the VMIT builder. The VMIT means virtual machine initialization table, and it is the configuration of the virtual machines. Both of these tools read a configuration file in XML and convert it to binary. Since these tools are qualified, you can easily do the validation on source code level, which means that you can quickly incorporate changes without doing the complete revalidation on binary level. When it comes to certification, we also provide you so-called certification kits. These contain all the necessary documentation to get your entire system certified, as well as the traceability where we provide tracing numbers for the tests, design, and requirements so that you can incorporate those numbers into your own traceability and provide the authority a complete view on the project. We have certification kits for avionics, automotive, railway, and security. In addition to that, there are also certification kits for our certifiable IP stack as well as the certified file system. So what is one of the unique features of our PikeOS operating system? It's the ability to execute software with different safety levels or security levels at the same time. That means that you can certify your critical application according to the highest level, for example, Del A, while you have a Linux running with a safety level of Del C in parallel. And the PikeOS operating system makes sure that there is no interference between those applications. This can also be used to separate your own software from open source software to make sure that there is no license tainting. So let's take a look at mixed criticality in times of memory and I/O partitioning. Due to the strong partitioning, any memory access that is happening by the Linux kernel cannot get outside the bounds of the Linux operating system, which is strictly separated from the others partition in this area. That means the system software statically at startup configures strict memory requirements that cannot be overwritten by the Linux at runtime. When it comes to denial of service attack, the Linux operating system has the capability to schedule the partitions in a strict order. This is called time partitioning, and therefore the Linux kernel gets an exact amount of time. After this, when this time elapses, the system switches to the other operating system. By means of this, even if there is a denial of service attack to the Linux kernel, there can be no effect on the other operating system, since in the worst case, the Linux can only use up its 20 time partition ticks in this example. Another important topic of newer embedded systems is multi-core. So multi-core computers are very common in the embedded market now. However, they still impose a problem for safety projects. The reason for that is that modern processors are architected for medium time management and not worst case execution time. That means that, for example, via cache effect, an application running on core A can have a negative effect in terms of performance on another application B running on another core. This is called cache interferences and can impose a risk on an application which is bound to deterministic behavior. The avionics has seen these issues and constructed a positioning paper called CAST32A, and it lists actions to be done which mitigate those risks. PikeOS has inherited all those mechanisms and is now ready to implement systems that are compatible with the CAST32A positioning paper. That, for example, is happened by cache coloring, cache locking, or cache partitioning, and fine-grained locking inside the kernel. Well, the operating system is not the only part which must be considered. It is always the application. So by running only non-critical application at the same time and doing a cache invalidation before you start the critical applications, you can make sure that the deterministic behavior is being kept. So when it comes to constructing multi-core safe systems, even in the context of safety, it is important to consider the hardware, the operating system, as well as the applications. So SYSGO can proudly announce that we have done all measures that are required to be CAST32A compliant. And in addition to that, a few years ago, PikeOS got the certification on SIL level 4 for multi-core systems in the railway market. today we also have an announcement to make. So we have Alinos, our Linux distribution. We have PikeOS, or called PikeOS Classic from now on, for bigger systems with an MMU. And now, this is a new product announcement, we have PikeOS for MPU, which is the full PikeOS API for controllers that do not have a memory management unit. This allows to have PikeOS running on systems that are way less complex and are ready for systems where hard radiation must be configured and single event upset. And actually, space was one of the major topics that drove the development of PikeOS for MPU. So as you can see here, the PikeOS for MPU architecture is almost the same as our standard PikeOS. So we can run multiple guest runtime environments on top of PikeOS. We can still run drivers in user space. And on the hardware side, PikeOS for MPU supports a whole set of drivers. For example, the Xilinx FPGA. What is also new here is intercore communication between operating systems. That means that PikeOS for MPU can communicate with PikeOS MMU if those are present on the same system. So PikeOS for MPU is like its bigger brother. PikeOS Classic is designed for the highest level of safety and security. It also has the capability to execute concurrent applications with different safety and security level, mixed criticality. It has time and space partitioning, and it shares the same native I, the same customer development environment, which is CODEO, the same qualification processes can still apply, and both operating systems share about 80% of the same code. Existing source code that you have can easily port it from the PikeOS Classic to the new PikeOS for MPU. Due to the nature of not having an MMU, the virtual address management and the ability to run a Linux operating system, of course, is not present within PikeOS for MPU, but it has address space protection, of course. It has the exception handling and interrupt processing, of course, the hardware abstraction, and the thread API are exactly the same. We also provide the full PikeOS health monitoring system. We have inter-partition communication as well as inter-partition communication. This is typically implemented by queuing and sampling ports, which come from the ARINC 643 standard. Finally, the current version of PikeOS for MPU runs in AMP mode, but this is only related to hardware. If you have a hardware where cache currency is present, we can also run in SMP mode as PikeOS, the bigger brother. Currently, PikeOS for MPU runs on ARM cores. These are the ARM Cortex-R52 and the ARM Cortex-R5. In the near future, we are going to support RISC-V, some PowerPC processor, as well as the 3-core processor. The memory requirement of PikeOS for MPU is 4 MB on the target system and as well 1 additional megabyte per processor core. So what you also can do with PikeOS Classic and PikeOS for MPU in tandem is to run them on the same hardware platform. For example, today we have the Xilinx UltraScale board here, and this allows to run a PikeOS Classic implementation on the Cortex A53 processors cores, as well as PikeOS for MPU on the Cortex R5 cores. Since PikeOS and PikeOS for MPU have an identical API and are running under the same development platform, CODEO, this allows simply to move tasks from one operating system to another one. And using the same API also reduces significantly the learning curve, as you can just apply the knowledge that you get from PikeOS. We will now show a short video that we put together with our partner Xilinx.
Computer-aided assistance systems are becoming increasingly important for industries such as avionics, automotive, space and railway. Applications such as object detection, machine-to-machine interaction via communication, remote sensing and the use of smart antennas require tailored solutions consisting of suitable hardware and software. With PikeOS for MPU, we set new standards in the development of real-time capable embedded systems. PikeOS for MPU is a real-time operating system for microcontrollers without a memory management unit. Simple applications can be created more reliable. At the same time, PikeOS Classic in combination with PikeOS for MPU can be used to run new heterogeneous multiprocessor systems on a chip. The clue? You can build it in a single integrated development environment. These heterogeneous multiprocessor systems on a chip make sense where computing power is required on the one hand, as in image processing, and on the other hand, a large amount of data is processed in real time at the same time. This enables applications such as real-time satellite transmission of video material or near-field radar distance systems in automobiles, which must be reliable and functionally safe. With PikeOS for MPU, PikeOS Classic and our Eclipse-based integrated development environment CODEO, we address these needs. In our demonstration we show you how it basically works. We use a Xilinx UltraScale board with a powerful ARM Cortex-A53 and a real-time capable ARM Cortex-R5. PikeOS Classic is running on the A53 with an SMP mode. PikeOS for MPU is running on the R5 with an AMP mode. We have developed 3 example applications: the sender, receiver and the bouncer. Sender and receiver are running on PikeOS Classic. On the other hand, the bouncer is running on PikeOS for MPU. This example shows how inter-core communication basically works. The sender on the A53 is distributing packages to the bouncer on the R5, which sends back the data to the receiver, also running on the A53. We can build all applications and the images of PikeOS Classic and PikeOS for MPU hosting these applications within one CODEO development environment. This is done via integration projects that store all the necessary configuration data and, once built, become the images of either PikeOS Classic or PikeOS for MPU. Via U-Boot and TFTP service, the images of both operating systems are downloaded to the Xilinx target board. You can see in the console that the receiver gets the data from the bouncer. PikeOS for MPU and PikeOS Classic will ease up embedded development and boost your embedded system project.
So, for the conclusion, I will hand over to my colleague, Dagen White.
So for Xilinx SoCs, in conclusion here, we're targeted for safety critical applications. We certainly have a focus on functional safety. We have increasing certification artifacts that we're generating under our functional safety efforts. Even today, we're adding more capabilities with Zynq UltraScale Plus, MPSoC, and going into Versal, we'll be adding more capabilities there in terms of data to support safety certification. Zynq UltraScale Plus MPSoC today is being designed into DAL A, B, and C applications. I'm hoping to see the first system to get certified in 2022 calendar year coming up here. So hopefully that'll be happening. Certainly there's been a lot of development. And like I said, these programs take 3 to 5 years to get into certification. So we're coming close to that now. For new designs, we have Versal ACAP, but the Zynq UltraScale Plus MPSoC is still a very strong solution for designs, new designs in avionics systems. And then going forward, we will have additional extended processors that are not yet available in Versal, and I see those as the next bridging device, from the Zynq UltraScale Plus MPSoC. So we'll look for those in the next couple of years here. Okay.
We learned about the hardware of Xilinx and the combination of PikeOS and PikeOS for MPU. We introduced our new operating system PikeOS for MPU, which has been designed for space applications, for systems which do not have an MPU, and therefore have a simpler architecture. We learned how to solve intercore communication challenges and how to use our development environment, CODEO.
Thank you. So on this slide, you see the contacts. At this point, I would like to thank the presenters. So thanks a lot for your time, and have a nice rest of the day.